Hello students, myself Professor Santosh Porki, Assistant Professor, EC Department, Basic Result Engineering. So in this video we will see the construction of a DC generator and what is the equation for the EMF and what is effect DC generator when the load is connected. So first we will see the construction part of a DC generator. So before going to start with the construction of a DC generator, first we will see what is the name of the generator. So generator is a device which can convert mechanical energy to the electrical energy. It means output should be electricity. So output it may be electricity. So again in electricity there will be two types, AC and DC. So if the output produced is called as a DC generator. Now this is the construction part. Outer part is called as a yoke and which is will be stationary. So this is not rotating part. And inner part will be rotating part, so that we call as an armature also. In the previous construction we used the word as a rotor, but here we are using the word is nothing but the armature. Armature, rotor will be same. Now the outer cover will be yoke. Yoke is made up of cast iron or it may be the cast steel. And for the yoke itself, the lifting eye at the base plate will be attached. Now for the pole, so pink color is called as a poles. So depends on the application, the number of poles will be inserted for the yoke, and the pole will be attached to the yoke by using the help of the nut bolts. And this is the pole, and this is the pole coil, and this is pole shoe. Pole coil is nothing but if this is the pole, if the wire is wounded, that wire connection is called as a pole coil. And the bottom of the pole shoe is in cylindrical in shape, because whatever the flux is produced, that should be uniformly distributed in between the poles and the armature. That's why the pole shoe will be, bottom of the pole shoe will be cylindrical in shape. So next will be armature. So armature is made up of the silicon steel, which is having a thickness of 0.4 to the 0.5 mm, and the armature having the uniform curves on the outer periphery, because here we are keeping the conductors, and these conductors may be connected in a lap connection or a wave connection. Lap connection in the sense conductors are overlapping one above the other. Wave connection in the sense it will be connected like a wave. So this is wave connection. Now next part will be the commutator. So commutator, which is a device which converts AC to DC, because whatever the electricity is produced, so that first will get the AC. So that AC has to be converted to the DC with help of the commutator, because the construction will be for the DC generator, and the inner part will be the shaft. So whenever the armature starts rotates, the shaft is also rotates. So this is regarding construction of a DC generator. In exam, the question may ask, list explain the construction of a DC generator with the parts. So this will be the answer. So next comes to the EMF equation. So first I am taking the parameters. Z is nothing but number of armature conductors, means this armature conductors are nothing but how many conductors, so that will be the Z. Flux is, phi is flux per pole. So what is the flux is produced, so that is the flux per pole. And N is speed of the armature, means at what speed the rotor will be rotates, so that is nothing but the speed. P is like this, how many poles are inserted, so that is the number of poles. A is nothing but the parallel path. Parallel path in the sense if it is connected in a wave connection, so this is one parallel path, this is going to be one more parallel path. Now EMF induced in one conductor. So whenever the stator armature starts rotating, so EMF will be induced in conductor. In one conductor, how much EMF is induced? Nothing but 5 Pm divided by 60. Phi is the flux, P is the poles, N is the speed divided by 60 seconds. So this is regarding only one conductor. If total EMF means how many conductors are present here, Z numbers, so that Z will be multiplied divided by 60 into A. And in a problem solving, if the connection is a lap connection, take A is equal to B. If the fourth pole is nothing but, so A is also 4. And if it is a wave connection, doesn't matter regarding the poles, always if the wave connection A is equal to 2 itself. So this is nothing but the wave EMF equation. Next come to the DC generator on load. So this is the symbol for the generator, and here the load resistor is connected. So this part is called as a field winding, and this part is called as an armature. So for the field winding, whenever the field voltage is applied, so due to the field voltage, field current is flows. So due to the current, the same current flows across the coil, the flux will be produced. Now whenever the armature starts rotates and armature having the conductors, as explained here, armature consisting of the conductors. So that conductor cuts across this magnetic flux, EMF will be induced. So this is the induced EMF. And across the load resistor we are measuring the terminal voltage. Here the main focus is the terminal voltage is always less than induced EMF. Terminal voltage is always less than induced EMF because of the three factors. So what are these three factors? IA into RA, ARD and BCD. So what is nothing but IA into RA? RA is nothing but armature resistance, IA is nothing but armature current. So whenever the IA flows across the RA, armature resistance, resistance is the property of opposes the flow of the current. So here some amount of the current will be reduced. If the current is reduced, the whole product answer is also reduces, and this is nothing but the voltage according to the Ohm's law. I into R is nothing but the voltage. So here some voltage will be reduced. Next is nothing but, and this is called as an armature resistance drop. Next is the ARD. This is armature reaction drop. Whenever the armature current flows across the armature, armature also produces the flux. That flux is opposite of the main flux. Here some amount of the voltage will be reduced. So this will be the armature reaction drop. Last one will be BCD. BCD is nothing but brush contact drop. BCD is brush contact drop. Armature on the shaft we are connected to some brushes. So carbon brushes to avoid the electrical shock. So that carbon brush is also having the small resistance. Again that resistance opposes the flow of current. Here again some amount of the voltage will be dropped. So because of the IA into RA, ARD and the BCD, terminal voltage is reduced because of these three factors. So we are concluded here, terminal voltage is always slightly less than induced EMF.